Hello everyone. In this video, let us try and solve this problem. We have when force P is applied to the rigid lever arm ABC in the figure below. We have the figure right here. The arm rotates counterclockwise about pin A through an angle of 0.05. Determine the strain of BD assuming all joints remain connected. So we have the figure. So what happens in this problem is we have ABC is rigid and then P is applied here at point C, which makes the lever arm ABC rotate counterclockwise. So it will rotate going in that direction at an angle of 0.05. Then the question is determine the strain of BD. So basically BD will most probably change in length. It will probably stretch. Okay, so let's try and solve the solution. Okay, so we know that ABD will now rotate counterclockwise. Okay, so if we simplify our figure just considering A, B, and D, we would get something along this triangle. We have the A, the D, and the B, wherein AB was initially horizontal. Okay, this would be the original designation or the position of AB, horizontal, but then it rotated. So this is now the amount of rotation of 0.05 degrees. Now we know that AB is rigid, rigid lever arm, so AB will not change in length. So this will remain as 400 mm. Okay. BD is now different in length because it has a strain, so it probably changed. Could grow or decrease, but most probably it will grow. So BD is now BD prime, no? Because BD is 300, so BD prime is now the deformed BD length. Now we need to solve BD to solve the strain. Now looking at this figure, there are a lot of things that we need. We need this angle. Let's name this theta. Okay, we need this angle. We need what else? We still lack a few unknowns. Now going back to our original given figure, if we just consider ABD and create our imaginary triangle, we have the triangle is formed from A, B, and D. No? A, B, and D. This is 400. This is 300. And assuming the hypotenuse side is C, this is right. Okay. If you notice, this angle right here, theta, is just the same with the angle here because this is the orientation of AB before it rotated, and this is also AB before it rotated. So this is theta. Now looking at this triangle, we can actually obtain theta. Theta to be tangent theta is opposite over adjacent. So we have theta is arctangent 300 over 400. We have 36.87. 36.87 degrees. We now have theta. We have arctangent 300 over 400. 300 over 400, 36.87. So we now have theta. We can also get AD from our figure here. AD is the hypotenuse C. And we know C squared is simply equal to 400 squared plus 300 squared. So we have C square root of 400 squared plus 300 squared, 500. So C is 500 mm. So you know this is now 500 mm. So looking at this triangle, we have two sides are given and one interior angle between the two sides, and we need to find the length of the third side. We can solve this using cosine law. We have for the cosine law, BD prime squared is equal to 400 squared plus 500 squared minus 2 times 500 times 400 cosine of 0.05 plus theta. So we have here for cosine law, we have the squared of the unknown side is equal to the squared of one side plus the squared of the other side minus 2 times the length of both sides, times and times, and then cosine of our unknown, of our known angle, which is the angle between the two sides. Okay, so solving this, we'll have square root of 400 squared plus 500 squared minus 2 times 400 times 500 cosine of the theta is 36.87 plus 0.05. We have 300 point what's this, 300.3498 300.3498 3498, yeah, 3.3498. So we get BD prime is now equal to 300.3498. Okay, so checking for the angle, we have it here 36.87 plus 0.05 plus 0.05. Okay, so we have 300 point, checking again, 400 plus 500 minus 2 times 400 times 500 cosine of 36.87 plus 0.05. Okay, 300.3498. 300.3498. Now we have the deformed length of BD. We need the strain of BD. To solve the strain, we have the BD prime minus the original length of BD all over the original length of BD. Okay, so we need this one. So we have 300.3498 minus 300 all over 300. So we'd get 300.3498 minus 300 all over 300. So we have 0.00116. 0.00166. This is 0.00166. This is now the strain. Now strain is unitless in nature, but it is often written with a unit, so we can either choose for mm over mm. Okay, I have the answer. Note that even if I write it 0.00116 meter over meter, it's just the same, because if whatever you convert below, it will just be cancelled out with whatever you'll be converting for the above. So that's why its unit is just mm over mm, or it could also be m over m or any other unit, as long as it's the same for the numerator and denominator. We'll use mm over mm because most of the given in the problem is in mm. So let's have our strain in mm. 0.001166. Okay.